Okay, so we're going to prove one of De Morgan's laws for sets. And all we're going to use is the definition of union, the definition of complement, and one of De Morgan's laws for propositions. Okay, so let's go ahead and get started with this. So let's start the proof. So we'll start with X is an element of A union B complement. So by definition, this means X is not an element of A union B, right? By definition of complement, right? So what this means is, so let me go ahead and go down here. So what this tells me is it is not the case that X is an element of A or X is an element of B, right? So this means, so X is not an element of A union B means that it is not the case that X is in A or X is in B. And the reason why I wrote it like this is because this statement is of the form, the negation of P or Q, right? Where X is in A is proposition P, X is in B is proposition Q. And what we know De Morgan's law, the negation of P or Q is the negation of P and the negation of Q. So what this tells me is, this means that X is not an element of A and X is not an element of B, right? Because now we got it from the form not P or Q to the form not P and not Q. And we know that the negation of P or Q is logically equivalent to the negation of P and the negation of Q. Okay? This also makes sense with the picture. Let's go ahead and draw a Venn diagram to sort of illustrate this. So we have the universal set, we have set A, and we have set B, right? A union B is this entire space here, right? It's this space that I shaded. Okay? So if X is not in A or X is not in B, right? If X is not in A union B, right? That means X has to be outside of those two in the universal set somewhere, right? So this means that X can't be in A and X can't be in B, right? Does that make sense? So now all we have to do is use the definition of X is not in A, so the definition of the complement, and then the definition of intersection, and then we'll be good to go. So this means that X is an element of A complement and X is an element of B complement. Okay, so now this gives us, by definition of intersection, that X is an element of A complement intersection B complement. So now we have X is an element of A union B complement if and only if X is an element of A complement intersection B complement. So what we have is we have that for every X, X is an element of A union B complement if and only if X is an element of A complement intersection B complement. And since we have this statement here, we know that A union B complement is equal to A complement intersection B complement. And that's what we set out to do.